an entire new series and new topics. And at any time if you'd like to suggest some topics for additional webinars, please send us an email, fill in the chat box, which brings us to those boxes on your screen. We have a Q&A box. That's how we'll be handling questions this morning. We'll wait till the end and then address them all at the same time. If Lawrence hasn't covered a topic, that shows up in the question box. We'll try to get to them all, but we are limited by time, but we'll do our best. So a couple of quick words about FlexTech for those of you unfamiliar with us. We are completely focused on contributing to the growth, the health of flexible, printed, and hybrid electronics. You can divide our activities into three distinct areas. First, we evangelize for the sector and the technology and advancements that it brings to the electronics area. We've educated many different groups, from government officials to paper manufacturers to automotive and packaging manufacturers. Secondly, we fund advanced and high-risk R&D. For over 20 years, we've been working primarily with the Department of Defense and the U.S. government on selecting and managing technical projects and demonstrator projects. We manage a PhD level group of we manage our technical council, which is a PhD level group. They identify and evaluate proposals for those projects of highest interest to the community. To date, we have managed over 160 projects with the results shared with other member companies, and that's in order to expand the knowledge base and to propel the industry faster and further. And lastly, we believe that connecting and educating professionals in the sector and all of those related sectors is critical to increasing the speed of adoption and innovation in the flexible hybrid electronic space. So we organize focused webinars and workshops, and of course our flagship conference, the Flexible and Printed Electronics Conference and Exhibition, each year in February. And of course that's coming up. We want to be sure everyone realizes that the event has moved to Monterey, partly to avoid the hotel nightmares that were created by the Super Bowl in Phoenix. But also we want to offer our attendees the intimate atmosphere that's most conducive to networking and building relationships in our sector. And we certainly believe you will find that in Monterey. We have 4 full days of activities planned starting on February 23rd with short courses, receptions, 2 full days of exhibition, and 3 full days of technical conference. The technical conference, the preliminary agenda has been released. Personally, I think it looks fabulous this year with over 100 technical papers and posters spread between 26 sessions. As you look at the session topics here, you'll note that all of the building blocks for finished products are here, and that's our intention. We include several that pertain to our topic today on the industrial internet. But first I want to leave you with this URL. You can find everything about the Flex conference there, and I hope you will flock to the site and register and plan your February around it. Back to our featured presentation today on the industrial internet. Lawrence Gasman will be our presenter. Lawrence is an economist by training, and as such looks at the business trends that affecting the areas and the markets for advanced materials. Lawrence will share his view of the industrial internet, what it is, how it's changing, and most importantly, what kinds of demands the sector will realize for products and services. We'll take the questions throughout Lawrence's presentation on the Q&A panel, and then we'll raise them after the presentation. I recommend staying away from questions that deal with particular companies or go too deeply into the technology. We're definitely focusing on the markets here. I'd like to stress that this will not be a technology-heavy talk. We will deal with those, the technology at the Flex conference in February. So save up your questions and we'll do some deep dives there. With that, I'll turn it over to Lawrence. We'll get some slides up here.
All right, from the start. There. Hopefully everyone can hear me. Hopefully everyone can see the slides, and hopefully I can transition them gracefully and successfully. So thank you for attending. Um, Here is a free ad that FlexTech grants us, and just a little bit about NanoMarkets for those people who don't know about us. We're an industry analyst firm, and we do what many industry analyst firms do. We publish reports, do custom consulting, run in-house seminars and webinars. We've been around, I think, 11 years now, and we covered many of the areas that FlexTech also covers, but in a different way. We've actually been covering sensors since our very early beginning, and it's becoming a bigger part of our practice for obvious reasons. This particular webinar is based on a study we released, I guess last month, called Markets for Sensors in the Industrial Internet. And we also have a companion volume, another report that's on sensors in the Internet of Things. And for the purposes of our work, the industrial internet is obviously about industrial and commercial applications, while the IoT for our purposes, and everybody has their own favorite definition, is more about consumer applications. And I'm going to be touching on some of that in the next few minutes as I talk. But let's kick off by saying, you know, this is all a lot of fun, and we keep seeing the industrial internet title and IoT popping up in promotional literature and in trade publications, but really what difference does it make if you're in the strategic planning business or the marketing business, the product management business? I mean, why should you care? Well, I think maybe that's always true with the kind of topics we cover here, but I think maybe it's even more true with the industrial internet, because the term industrial internet is really due to one company, and that's General Electric, GE. So what somebody might possibly say is, look, this is just a GE promo. This Gasman guy gets nice big checks from GE, but no, we think it's bigger than that. It's certainly good of GE to come up with this definition, but we think it's a very useful definition, and of course, not just we do, but they have gotten the support and cooperation from some very big corporations. Two that spring to mind in particular are Intel and Cisco. Intel obviously hopes for big things in terms of the number of chips being sold, and Cisco, which is really the premier networking company, is hoping for big things in terms of networking. So what are these big things? Well, from the semiconductor industry perspective, to paraphrase Carl Sagan, what they're looking for is billions and billions, billions and billions of chips, of course, and they see it as an evolution going way back, literally into the 50s, I think. The semiconductor industry, to the extent it existed, was shipping in the tens or up to the thousands eventually in terms of CPUs, and they were shipping them to mainframes, and there weren't very many of those around. And then came the 60s and 70s, and we were into the thousands and thousands with the mini computers, and then PCs into the millions, eventually tens of millions, and now hundreds of millions if you include tablets. And then we moved to cell phones, and here we're talking about almost 2 billion shipped every year. So what the semiconductor industry is talking about is units that could be brought about by the Internet of Things that are at least an order of magnitude and perhaps 2 orders of magnitude greater. You see numbers, and they're not from us, but they're believable, I think, that you could have 35 billion devices in the Internet of Things. And that's a lot of good news for the semiconductor industry, and also to some extent for the sensor industry. It would make the sensor industry just balloon. The sensor industry has been around for a long time. Actually, Heidi and I were talking about this just before the webinar, and no offense to anybody from the sensor industry, but in some ways it's been a sort of boring old industry that mostly sold to automotive and a bit to medical, and there was certainly some interesting technological stuff going on, and nanosensors and that, but they didn't. It just wasn't. It was a fairly mature industry in the sort of general sense. And now we're seeing, if you just go to the Sensor Show in June or whenever it is, it's moved from being a show about automotive and aerospace to being this big Internet of Things. Suddenly it's sexy and colorful, and I think, look, I've seen this all before in the telecom industry where, go back to the 70s, and telecom industry was pretty much all around, but it was about telephone companies and maybe the military, and then it all suddenly exploded. So there's at least a prima facie case that can be made that this is what's going to happen in the sensor industry with Internet of Things and industrial Internet as part of that. But I did say that we were going to talk about the industrial Internet today, not so much about Internet of Things. And I think, throughout this, one of the big takeaways from this should be that the good news about industrial Internet is that the proof of industrial Internet based, say, automation can be proved. I mean, you can actually do the math. And that makes it a much better business proposition, a less risky one than, say, well, a good example actually, home automation in the IoT. Home automation has been tried so many ways before and never really taken off. So there has to be an element of skepticism about whether it's going to this time under the IoT umbrella, whereas if you can really show that you're saving a certain amount of energy or boosting up the supply chain within industrial Internet, it can be demonstrated in a matter of experiment, then that makes the business case for industrial Internet vis-a-vis IoT in a consumer sense that much more provable. And as a final sort of cautionary note, I think it's interesting there's a sort of parallel development outside of IoT, which is the wearables thing, and they're closely related in a number of different ways. And what we've been seeing in the last 2 months in wearables is after 18 months of fuss about Google Glass, it now seems to be having its problems. And while I read every day about the demise of Google Glass, and this is an exaggeration, but that's what it seems like in some of these trade press articles, I also read every day about industrial applications for smart glasses appearing. So it may be the industrial Internet is the first bit of the IoT that actually becomes commercialized because you can do the math and show that it makes sense from an end user application. Well, I seem to have left out a slide, which is very strange, but I'm going to talk about it anyway. And that is, I'll leave these numbers up so you can copy them down or something. But there is a slide it was the evolution towards industrial technology, and I really wanted to make some distinctions there because, of course, sensors in industry and commerce have been around for a very long time, and I really wanted to show where we are right now. What I called stage one conventional technology was really just simple sensors maybe connected to a hub for a single purpose, and here I'm talking about fire alarms and other simple safety systems, and that's so 1960s and 1970s. And stage two is good old 20th century technology. You probably all remember the 20th century, and that is computerized automation that often dates back to the mini-computer era, even if it's been upgraded in some ways for PCs. And that includes the current generation of building automation systems. Also, our little newer RFID-based industry tracking of automobiles and highways. Now, I wanted to distinguish the industrial Internet because I think it's something different, and that's really what, when you burrow down into these definitions and things, you can see that it's different, and it's also what's creating the opportunities. What we're talking about here is software driven with sensors everywhere interacting with each other, internet networking throughout, providing real-time information. And, again, this is the kind of ideal version of it. As I think I say somewhere else, actually some things are going to appear on the market called themselves the industrial internet that don't actually use the internet, and we've been fairly strict in our numbers, and some applications that use the internet that's stretching the definition of industrial internet to include in it. But I think the big thing is, while in the earlier stages we were talking about a few tens of sensors, what we're talking about here are numbers of sensors installed is probably 2 orders of magnitude than anything we've seen before. And of course that is at essence what the nature of this opportunity is. So we really are on this slide now, and again apologize for the missing slide. But these are the numbers we finally came up with. I put in a few years to give you some idea of what we're looking at. This is supposed to be revenues by a complete sensor, and we're not talking about a sensor chip, we're really talking about subsystems. And some of these subsystems, and this is another distinction from the consumer IoT, are fairly expensive kinds of products. When you're talking about pressure sensors and you're talking about the consumer IoT, you're probably talking about some ITOE sort of thing, or something you put your finger on, or something like that. When you're talking about pressure sensors, say in factory automation, you're talking about something that has, can deal with a 2-ton press pushing on it. So you're talking about real significant devices here. In the study, we talk about what the price points are for these things, and where we got the numbers from and all that. But we're generally talking about serious sensors here, serious subsystems, and also, as an aside, looking at it from an opportunity analysis point of view, these are the kind of systems where there's probably more opportunity to distinguish yourself in the marketplace than, say, with a little sensor that goes into a, cell phone or something similar than that. So look at 2014. A lot of this is just focused into internet-connected sensors in industrial and commercial building automation. There's a fair amount of that if you look at, say, smart lighting and that kind of thing. But obviously, as I'm sure you all expected, we're expecting that dominance to decrease somewhat over the period. So that when you get to 2019, you've still got a huge chunk of this in industrial, commercial and building automation. You've got a fair amount in the electricity grid. This is a smart grid we're talking about, which is really about sensors. Sensors have always been a fair amount. And a bit in factory automation. I mean, significant enough, I think, to make a good-sized business for all but the very largest companies, and maybe them too. By the time you get to the end of our forecast, you're looking at 3 segments that really dominate the whole market, and that's really another of these takeaways. We were actually quite surprised when we started looking at all the applications that were industrial, and it's fairly easy to find that out because you just go on like GE's website or Cisco's website, and they're full of examples. But when you start looking at the underlying addressable market, when you start looking at some of the applications that are pretty entrenched, then you have, and also, some of the replacement times for some of these products, it's hard to see how you get to the really big markets except in those 3 areas that I mentioned. The electricity grid has been rapidly upgraded in Europe and the US, so timeframes have speeded up, and as I say, commercial building automation is fairly big to begin with and is being speeded up by the cost of energy, although that's beginning to change too, and I'm not sure we really took that into consideration. Anyway, it's questionable how long that will continue. A lot of it is about networking. and you hear a lot about IPv6, the latest internet protocol, and its ability to provide addresses for sensors everywhere, and I think that's important in terms of some key enabling technology for most of the numbers you see here. But it's also worth mentioning the point that IPv6 has been around a long time. So sometimes, again, these things change at a fairly small pace, slow pace, I think I mean. Well, that was the slide I wanted to show you. I must have copied it to the wrong place, but I told you everything I wanted to tell you about that. This is another slide, and really the main takeaway I want you to have here is what we were seeing. We started off when we wanted to do our forecast. We said, well, do forecasts about all these sensors, and we soon found that actually we kind of had to. One of the interesting things I think about the industrial internet that we saw as we did our study is it seems to affect almost every possible kind of sensor, and we really didn't look at biological sensors all that much, but you could probably throw those in here too. So you can read these lists as much as I can, and the key thing is this is going to create opportunities for a lot of different kinds of sensors, and from the point of view of the sensor sector, the sensor industry, there is opportunities there for everyone. Now, I don't really expect you to go into the fine lines that are at the top, like Fraunhofer lines, but and you shouldn't take it too seriously because the scale on the left is essentially in billions of dollars, so there's even the small ones are significant amounts of money. But you really do need to take, this isn't just about one or two kinds of sensors, it's right across the board, and also there are some specialist sensors that, like an AMI sensor that would be specific to a particular kind of application, in that case the smart grid. The other thing I want to mention is there's an opportunity there, which I didn't break out in this presentation, for selling sensor hubs. I think there's a vision, and I think it's a long-term vision, of each of these sensors being little devices that are connected directly into the internet via IPv6, and that's probably the way we're going eventually. But there's so many companies in this with so many proprietary protocols and so many features that are proprietary to them or special to them in some other way, that I think you're going to need some kind of intervening device, and that's going to be a hub. So the sensors will go into the hub, and then the hub will connect to the internet through a router, presumably. So we've actually broken out, the numbers you saw include the II sensor hubs, industrial internet sensor hubs, which in many applications are actually going to be a significant chunk of the business. And by the way, in our IoT study that we just published, I think the press release goes out tomorrow, there is a similar kind of phenomena where the hubs make up a fairly sizable kind of part of the business. And that's actually good news, not so much for the sensor industry as for some of the traditional data communications industry, who I see as being part of this whole story. Cisco's involvement is part of that as well. I made some general comments about the industrial internet and about sensors, but what is it about sensors in particular? What is it about the industrial internet that's driving sensors in particular? Well, first of all, again, sensors have been around in industrial environments for a very long time. If you look at it, say, in the oil and gas industry, and you look at SCADA networks, it's all about sensors. They've been sensors of one kind or another in industrial machinery for probably 100 years, for all I know. But I think the big thing is that what we're talking about now isn't a sensor here and a sensor there. So if you know that your machine's going to not overheat or something, we're talking about sensors covering entire areas, not just a few sensors here and there. And that, as I've written down here, potentially leads to an exponential expansion of automation sensor market because entire areas are being covered. And then the other thing is many more functions of equipment are being monitored. So to take the example I gave about a machine that has a heat sensor in there because you want to make sure the thing isn't going to blow up while you're working, because that's a critical issue for you on that particular machine. But now you're going to monitor it for efficiency and effectiveness and whether it handles one kind of material better than another. So this, all these machines gradually become sensor-laden, entirely new kinds of machines. And there's a consulting project that I'm working on right now, which is essentially about, well, gee, is there an opportunity for people to come in and provide sensors to, I was going to say to older machines, but actually the machines that we're looking at are really not that old at all. So maybe there's a, this is becoming so critical, or will become so critical, that there are third-party opportunities as well. Certainly, it's probably going to create opportunities for new kinds of sensors to appear, either new technologies or just things that sense different, newer things, which also brings into it something I'll mention a couple of times, but was really kind of critical to both IoT and the industrial internet, and that's the whole idea of sensor fusion, which is really finding a way to coordinate all the different sensors, usually through some kind of software. In the past, sensors that can sense multiple things have been around, but there were things like smart noses and smart tongues, but they're very expensive, which is exactly what you don't want in the industrial internet or the IoT, and still had limited possibilities. But if you've got a machine that you're monitoring for heat and for vibration and for, I don't know, proximity to light, I'm just making things up now, but each machine will have its own requirement. You want to coordinate that in some ways. And at the same time, while it's obvious from the examples that are usually cited in these cases that what you're talking about most of the time is really large machines run by really large companies, we can only assume that the industrial internet concept is going to start moving down to smaller businesses. There's plenty of machine shops around, and maybe that isn't going to happen there tomorrow, but eventually, as a matter of competitive pressure, we think that will also be a market for sensing subsystems and machines embedded with a lot of sensors. I noticed I'd put on this could take a few years to happen. I wrote that, but I think by the time you get down to small machine shops, there's probably going to be more than just a few. But there's plenty of medium-sized industrial firms, the kind that do $200 to $300 million, where you're going to start seeing machines that need to be tied into the industrial internet for one reason or another. So moving on. The slide here is denser than needed. I wanted to give you some introduction to what's in our report, and hopefully you'll want to come back and buy the report and find out even more. But at least I want you to be able to study this when you have access to the slides and a bit of free time to see what other issues, because there's only come up because there's only so much one can talk about in the time frame that a webinar takes. It turns out that the industrial internet tied to some other big issues that are kind of hyped around the areas that we tend to talk about in these webinars, but they're related to particularly to sensor things. So big data is really the idea that huge data sets can be analyzed through high-performance computing better than they can be if they're broken up into smaller data sets. And I won't deliver a talk on high-performance computing, but it's much easier to build a high-performance computer now using PCs than it was 20 years ago, say, when you had to actually go out and buy a single dedicated supercomputer. But sensors are very intimately connected to that in the sense, again, pardon the pun, in the sense that sensors are often the source of big data. So, the causality runs in a number of different directions, but what we're talking about here is sensors in the industrial internet and in Internet of Things, essentially feeding into high-performance computing centers, and so the Internet of Things would be kind of pointless if, and industrial internet would be kind of pointless if it couldn't, in fact, be processing the data that comes from those sensors. So an intimate involvement then. IoT, I've already discussed how we see the differences on that. Most sensors used in the IT and industrial net are usually off-the-shelf devices right now. And at best, they're being adapted for internet connectivity in one way or the other. But we would expect, and we believe there's an opportunity for more dedicated devices. I think all we're seeing there is something we see in many other markets where people, when they're first getting into these new technology environments, are using what they can get off-the-shelf stuff, which is originally intended for something else, and that will change, and that probably change quite quickly, actually, and that may be one of the most quickly evolving opportunities for the sensor industry. Advanced manufacturing really is a topic all on its own, one of the things that I just want to sort of highlight here is mostly in the past, when you talked about sensors in advanced manufacturing environments, or factory automation or whatever you want to call it, you've been talking about putting the sensors into the equipment, and you largely still are. But now we're seeing materials themselves being embedded with sensors, so that the company who's doing the manufacturing can track the materials around the factory and perhaps beyond that, deeper into the supply chain, and also get data on processing so that they can understand how the materials behave during the processing and what materials they really should be using. Sometimes that matters, sometimes it doesn't. It probably doesn't matter in making cases for cell phones, but say in the aerospace industry, materials are everything, really. There's a number of key aerospace standards for quality control for all too obvious reasons, and they involve materials to a great degree, and if you can embed them constantly with sensors that would constantly provide information, that can be very useful in compliance with, if we're talking about aerospace, with certain international standards, as well as the kind of things in this country that the FAA would monitor. Business data center expansion really is a slightly separate issue. Go back a few years and most businesses really didn't have data centers, but even medium-sized businesses now have sophisticated data centers, and again that really ties into the big data thing. We've now got the capability to do something with those centers, even in relatively small firms. Now, what kind of, again, I listed all the possible sensors at the beginning of this talk, and we could go over each one of those and talk about requirements. Obviously, that would take more than 40 minutes or so that I've got to talk about this. And there are some very key things. I think most of them are fairly well known. certainly low cost. And the point there being that sensors, even at the level that we're talking about in the industrial internet, aren't that expensive. But if you're really talking about putting billions of sensors in, then the aggregate can be really large amounts of capital expenditure. And whereas somebody in, say, a smart grid might not have thought about sensors being an expensive part of their expenditure, or in factory automation or building automation, that if you have sensors everywhere, that situation could change. Low power, again, a well-known thing, really the same calculations. No sensor has huge consumption, but when you start adding the billions and billions, you start ending up with very significant amounts of power consumption, and actually generates heat, so you need building automation, actually. So it's amazing how these things going to go in circles. So I think, you know, low power can be new forms of architectures for the chips and for the sensors. They can be new kinds of materials, such as, you know, nanosensors. You know, another way of looking at that also is new kinds of power sources, and especially energy harvesting. So that, you know, even if the power consumption can be quite high, the actual power itself can be relatively large. And of course, all of those design strategies for sensors are going to be employed. And you know, I'm at the in the belief that we've still got quite a long way to go on that. Ruggedness and reliability, key difference there between the Internet of Things and the consumer Internet of Things and the industrial Internet. Industrial sensors are just going to have to put up with a lot more, basically, crap than in the consumer things. So we're talking about heat, cold, dirt, EMI, RFI. You could throw in radiation and probably a few things. So you're talking about much more sophisticated sensors, you know, that obviously has to be part of the story there. Appropriate communications interface. I mentioned IPv6 compliance. Again, be aware, there's nothing new about IPv6. People were talking about its implementation best part of 15 years ago, and probably much longer. Where there's a kind of standards mess, and you could do a whole webinar on this, is what standards will actually be encompassed and used in the Internet of Things and the industrial Internet. I guess the standard that's winning is the wireless sensor standard called Zigbee, because it's low cost and it has low data rates. But for most sensors, not all of them, some kinds of image sensors actually have high data rates. But for most sensors, you can do with things that are measured in kilobits or tens of kilobits or maybe sometimes hundreds of kilobits. Zigbee will do that. But you'd probably have a Wi-Fi connection from a hub if you didn't actually have a wired connection, but all sorts of other things flowing around. Bluetooth has extensions now that are appropriate to the Internet of Things. There's NOcean, which is for energy harvesting sensors, and gee, I feel like I missed something important out there, but there really are a lot of them, including proprietary standards that are emerging. So there's going to be, you know, if this whole Internet of Things and industrial Internet takes off, there's going to be standards wars with each major company supporting areas in which they're competent to produce very large quantities of these chips. But as I say, it kind of seems like Zigbee is the one that's out there right now. How long that carries on for, anyone who is old enough to remember what happened in local area networks knows that some of those standards, which everybody knew was going to succeed back in the 90s, are now ancient history and no more. Security, and again, another topic, which is A, current, B, you could do a whole webinar on it, on C, it's kind of a mess, is security. And depends what industry you're talking about, but you can easily see that security is a very important issue here. There's certainly privacy-related information in building automation and also in the smart grid. In fact, there's I guess in the smart grid, it's actually an issue of some political concern, and that all needs to be sorted out. Cost and other things, and the appropriate software is still the relatively early stage. And of course, billions of sensors everywhere is pretty much a security breach waiting to happen. It's hard enough to make sure that somebody isn't tapping into your fiber optics or into your wireless connection when there's only 10, 15, or even 100 connections. But if you've got billions, well, lots of luck. And I'm not going to say too much about software. There's really a lot going on in the whole Internet of Things software business. And there are those who say that this is really all about software anyway. And the sensor fusion thing I mentioned earlier is also really a sensor, it's also really a software area. Well, coming to the end, I just wanted to give you some idea. I mean, I talked about the economics of all of this and why you should care, why there's going to be opportunities and how big those opportunities are going to be. I think it's just useful to get some idea of what's kind of going on right now, and rather than give you 15 pages of list of companies that deploy them, I thought I'd just mention a few of them. And this is just in factory automation, which isn't even the largest one, but they've got some nice prominent names here: GE, GM, Harley-Davidson, Intel, Raytheon's, Black & Decker, and Siemens. All of these companies, or several of these companies at least, GE, Intel, and Siemens, certainly have a commitment of being actual players and suppliers to the industrial internet. So you need to be a little wary there. They have a dual purpose in actually deploying these things, but still, it's kind of interesting. So GE is got 10,000 sensors on its assembly line and its battery plant in New York, and 10,000 sensors, if you go back 10 years ago, that was an extraordinary amount. And now you're beginning to see that happen in leading edge plants. At Harley-Davidson, you've got sensors feeding information into a management system. I think the takeaway there is really, look at how many different kinds of sensors are being used. And then kind of just interesting stuff like at GM, where they use climate sensors to see whether it's too humid to paint a car. Well, I'm guessing, actually just guessing, that they did that to some extent going way back. But if you have really detailed sensing, you can fine-tune your decision-making on that kind of thing, and that can, if you're in a home and you don't necessarily want very detailed information on humidity, but if it makes a difference of whether you paint today and reallocate resources or not, that can make real money differences. Intel's kind of interesting because it's actually a little difficult to determine whether they're doing experiments with Arduino boards in order to promote their sensor and related chip business, or whether they're doing it because they really want to see what goes on and if they can improve their own efficiency. I don't know. But again, you could really write a lot on just what people are doing with these things, and I put it forward primarily to answer the question that I had at the beginning, which was what difference does it make? Well, it seems to me that a number of companies that are really first-rate, tier-one companies do think it makes a difference, and this chart kind of indicates that. With that, I want to thank you for listening to my stuff. This is a little bio of me. It's a fascinating story, my life, but I'm guessing that I'm the only one who actually thinks that, but so I quickly go over that, and thank you again. This is our contact information. I believe this will be available at the FlexTech site. It will also be available on our site, which, surprise, surprise, is www.nanomarkets.net. With that, I'll close.
Well, thank you very much, Lawrence. That was, I think, a very realistic view of the markets and a great introduction to all the pieces of the industrial internet, certainly focusing on the sensors. We do have one question here about, and I encourage everyone else to put those questions in the Q&A box. I think we have a few minutes to get to them. One question is just asking for more specificity, if you have it. With all these sensors, how would one constantly monitor the incoming data and make sense of it? Have you found in the research any tools that stand out in terms of doing that at this point?
It's a really good question, and I kind of skirted over that a little bit because, FlexTech, and to some extent at NanoMarkets, we tend to talk about hardware rather than software. I mentioned software a couple of times, mostly in the context of sensor fusion, and that's a lot of what that's about. Hey, we've got this stuff coming in from monitoring heat. We've got this stuff monitoring gas. How do we put that all together and make sense of it? Again, that pun about making sense of it. And that software is only beginning to emerge. There's a few specialist software firms around who are really working hard on that. My impression is that that software is very far from mature yet and does an adequate job, but still got a ways to go. I think one of the reasons, again, something I mentioned earlier, that this is being implemented mostly at very large tier 1 firms. I get those examples at the end of my talk. One of the reasons is that to some extent they can do their own internal software development or work with consultants, whereas, if you're a company making, even if you're a company making, say, small sports cars, you really can't do that. So it's going to be a while before those things are implemented. And that may be, and maybe this should have been in my slides, but that may actually be one of the things that holds us back a bit, is lack of adequate software. It could take 2 or 3 years before you really see these things starting popping up. And as I think everybody out there is aware, there's always great and pretty ads for the latest software from some company you've never really heard of. But when you buy it and implement it, there's more problems than there are successes. So I think we've got a ways to go on it, and I thought it was an excellent question.
To that end, that's what certainly popped out in my mind was just kind of a lack of human resources devoted to this effort at this time, and maybe training side, both designing and using the systems, and of course managing the data. Do you have any comments on kind of that the human resources side of this all? People?
Yeah. I mean, I think it's bigger than that, Heidi. Actually, I think that so this brings together, everything I've talked about. It brings together the sensor industry. It brings together the communications industry. It brings together, the big automation firms, who incidentally, have different groups working on building automation and, I don't know, whatever, automation of transportation. And those guys haven't necessarily talked to each other very much in the past. So on the training side of things, it implies, multidisciplinary training, and there's always challenges with that, because not least of which is you get somebody coming in there from the sensor industry, and they know everything. So they're 45 years old. They know everything there is to know about sensors. They have to sit through the sensor training. But then you mention IPv6 or a fiber optic connection, and they go, what's that? And then, you're boring the people from telecom. So I think it's a challenge to create modules that are training modules. I mean, the same issue actually impacts the business model. If you're going to implement all these things, you have to know people who are in sensors and materials and understand factory, just to put together a package that you can sell to some of these companies. In some ways, that's only going to get harder because, if I'm GE, I'm part of this anyway, so I can help you implement it. If I'm Siemens, same thing, but if I'm the, J.S. Smith metal bending company, I really want this because it's going to make me competitive, but I want some third party to come and put it all in. And it's hard to imagine how that third party comes up with a business model that's going to allow it to make money from all that. I think it will happen through, essentially this new idea of business ecosystems where there'll be a cooperation between various groups, and to some extent you're beginning to see that already. So a long way to go on a lot of these things.
And here's a great question just kind of rolled in. In your mind, is there any role for public sector research labs to help the industrial internet develop? For example, is there any enabling technology that the private sector isn't willing to develop on its own? Somewhat related.
I think I should declare a bias here, and if you don't know what I'm talking about, look up my name. So my instinctive answer is no. I mean, I'm perfectly honest. What worries me about that is somebody invests. If you put money into it, you have to put money into something. I mean, it might be sensor fusion, or it might be new materials for. But the only reason for putting it in is because you guessed that this is going to make money in the long term. And my concern, and this isn't a political webinar, is that governments aren't necessarily very good at that. I've written a whole book on this if you want to know, so I didn't know I was going to get that question. That's a separate issue from governments putting money into basic research. And a lot of this stuff, type in, instead of spending your time finding out what I do in my life when I'm not writing about technology, type in nanosensors, and you'll find that a lot of the really interesting stuff is going on at universities and that kind of thing, where a lot of government money, state level and everything else, goes on, and that's very valuable because it's pure research. So I think that's the answer to the question, but there's a lot more I'd like to say that I'm not going to say on FlexTech.
Well, and of course, FlexTech, we feel like we do have a formula for that sort of thing, and letting the industry decide and find paths for that versus having government, bureaucracies decide. So anyway, you're right. That is totally a conversation for another time.
Let me say one more thing about that.
Yeah, go ahead.
The government itself is a very large purchaser of this stuff, and in that sense, of course, they're just another customer, and they have every right to have a role in it, and should and will. So that's another aspect of it.
And as David Barnes points out, there might not, governments drive communication protocol de facto standards for security, which I think we'll see people talking about already. Okay, here's another one. With many temperature and humidity sensors already available, what features will be needed for the future generations of temperature and humidity sensors? Small form factor, accuracy, detection speed, any others?
Let's see, small form factor. That's something, honestly, I should have put on one of my slides when I was talking about key things. These do need to be small form factor. If you think about putting billions of things around your factory, or in the case of a factory, hundreds of thousands of things, they really can't be that big. And this is incidentally, this is an issue that the data communications business has faced for many years. You know, there was a time when you just had that nice little Ethernet plug in the back of it. Now you need 15 Ethernet plugs, or 30, or 50, and so they have to be smaller, and the transponders need to be smaller. So that's a whole issue on form factor. I think that's actually very important. I guess sensitivity is going to become a bigger issue, partly on a positioning basis. You really want to see, you know, different parts of your factory or different parts of the grid that may not be very far away and how they differ. Because, again, I think there's a sort of presumption here that all information feeding into the system is you know, is useful at some level. So I think certainly sensitivity. And there, I think the whole nanosensor thing is, you know, has got a long way to go. There's been a lot of very good work done by various organizations, including commercial organizations, for at least 10 years on nanosensors. You know, a lot of it has yet to be commercialized. So I think that's another thing. I guess the other requirement, and I did mention this, is internet connectivity. It's not, you know, not until very recently the first thing that sensor makers thought about. And in some areas, it's mentioned in one of the slides, but I didn't really bring it out, internet has just not been a real consideration. So in transportation, actually still in the automotive business, which isn't included in those numbers, we included it in our consumer thing, internet connectivity is something that nobody's really considered, either because it didn't do anything useful or because proprietary protocols you know, seem to work just fine. I may have forgotten a couple of things, but those things really stand out to me. And the form factor is an excellent point. Whoever asked that question, I should have mentioned it.
All right, very good. We're kind of running out of time, so one really quick one here. You made mention of an upcoming sensor conference. What was the name of that conference again?
Oh, I think it's just called Sensors. So the next one will be Sensors, you know, 2015.
Okay.
I have nothing to do with the conference. It's in Rosemount, Illinois, or thereabouts. And it's sort of in the Michigan, Illinois area because that's where the automotive business tends to be. And they've been doing that for a very long time. You know, as I mentioned, what's really changed is it used to be like sessions on automotive sensors, sort of aerospace, and a rather Rust Belty kind of conference. And now it's all, you know, bright colors and Internet of Things. And it's in June, I think.
June. All right. Okay. Well, that and you know, I think that take a look at the Flex conference agenda, because if you're doing sensors on any kind of flexible substrate or looking for small form factors, there's a ton of papers that will impact the sensor market and several on sensors, including in the nanobio session, lots of sensor papers for sensing those biomedical traits. So I want to make sure I mention that as well. And let's see, I think that's about what we have for today. I want to thank you, Lawrence. Thank you for all of your expertise here. As you say, you have the study, the report that's out. And for more detail, get there, go to the conference. Lots of different ways to get more data on this. Thank you to our participants. We hope we'll get you information on the next webinar coming up, as well as please do check out the 2015 flex.com site. Thank you very much, everyone, and have a good day.
Thank you.